So throughout lesson 2, we're going to be focusing on variables and objects and how we can use these as we begin learning about game design. So you hopefully have seen variables before. Some of you have encountered objects depending on your background in computer science, and we're going to explain the differences between variables and objects, and then we're going to talk about how we declare, initialize or instantiate, and assign variables and objects to have various values. So keep in mind that's where we are headed throughout this lesson, that we can explain their purpose, that we can explain the difference between the two, and then that we can basically use them in game design. So to begin, we're going to touch on a few key computer science vocabulary terms. So first, C#, which is the language we'll be programming in MonoGame, has multiple types of data. And so these are called data types, and you'll see here from the definition it essentially is describing the types of data or value that a program can hold. So throughout this, we'll be looking at two different types that we'll be using pretty heavily. We'll be looking at variables, and then we'll also be looking at objects. So the next few slides will cover these two topics. So to start, let's talk about variables. And variables, when we give them a name, are essentially the name of a location in a computer's memory that stores a piece of information. And variables can only store, as you can see here from the definition, single pieces of information. So essentially you can think about a variable like a mailbox. So a variable holds a piece of information, so that's kind of how it's like a mailbox. Now this variable mailbox is very specific. It can only hold one piece of information, and then every mailbox has an address or location. So my mailbox at my apartment is very specific. It's in my apartment building, and it is for my specific apartment number. Variables are the same way. They have a specific location in the computer's memory where this value is stored. So it's holding one piece of information at a very specific location. So that's the big thing behind variables. And as we create variables, every time we create one, we are creating a location in memory, and then we are storing one singular piece of information inside of it. So in MonoGame and in C#, we will primarily be using 6 basic variable types. So here I have the 6 listed out. You have a byte, an int, and a double. A byte holds the numerical values from 0 to 255. So if you know that your numbers will not be larger than 255, a byte isn't a bad idea. Then you have ints, which hold positive or negative integers. So if you know that you're going to use positive or negative numbers that do not contain decimals, that's what the integer values hold. So note from here, they do not contain decimals. And that is because the double here holds any type of number including a decimal. So basically byte, int, double, as you grow from byte to int to double, you are holding a larger set of numbers. You go from 0 to 255, then to a larger set of integer numbers, and then to a larger set containing decimal numbers. So these first 3 here are the number variable types that you can have. Then you also have ones that hold those letters. So you have a char, which holds a single character, and then you have a string, which can hold a line of text inside of quotations. So if you had a message you wanted displayed or something like that, that would be held in a string. And then you also have a Boolean value, or a Boolean variable type, that can hold true or false values. So you have your numbers, you have your letters, and then you have true or false variables that you can, in fact, create. So variables will be used quite often in game design. They hold all of the key information. So here I just listed a couple. There are a multitude more of variable uses in game design, but here you can see just at a basic level, you could use the counter, you could use it to keep score, could use it to track your health, could use it to track the speed you're moving at, use it to track your location and basically changing movements there. You could use it to track the time, the lives remaining. The possibilities are endless. So as you begin each game that I'm asking you to create, keep in mind you need to think through all of the variable values that you'll need to track the information that your game is required to keep track of. So in MonoGame, it has some very specific variable name requirements. Here you'll see that they are listed. So first, you must start with a letter of lower or uppercase. So you cannot start with a number, you cannot start with a symbol, you must start with a letter. Then from there, you can include any combination of letters, numbers, and underscores. I know that when you guys were in Visual Basic, if you took the intro class, that you could use various symbols to dictate whether you had an integer versus a string, but in C# you can only use letters, numbers, and underscores. There are no other symbols allowed. Then your variable name can be of any length, but you should be choosing a length that makes sense. So if you're using the word supercalifragilisticexpialidocious, keep in mind you're going to have to type out that variable name every time you use it. So you should be having an appropriate length, but there is no limit. So you could have a 20-word variable name if you wanted, or a 20-letter variable name if you wanted, but that doesn't really make much sense. And then the last piece here is that variable names are case sensitive. So if you have something like hello, and you have something like a capital H and then hello, while they're the same word, your computer actually views these as two different variable names. So once you choose a name, keep in mind that your program is case sensitive. So capitalization versus non-capitalization matters. Now from here, this last requirement in blue is my requirement, because when I read your program, I want to be able to understand what your code is for. Your variable names should relate to the purpose of your program. So if you are creating a variable that's meant to hold a counter and you name it Bob, doesn't really make much sense. It's not going to help you as you're coding. You're going to struggle to remember what Bob represents. So make sure that the name relates to its purpose in the program. Health remaining, lives, timer, whatever it may be. So what I'd like you to do here is pause the video and go through these 10 and decide which variable names are appropriate and which are not and why. So again, pause the video, just jot down in your notebook which one of these variable names are appropriate, which are not, and then on the next slide we'll walk through which are appropriate and which ones have errors and would not be able to be used in C#. So on this slide, the blue variable names are appropriate and the red variable names are not. So I just want to talk through why these ones in red will not work. So quickly, this first one, hello, because it starts with an underscore, that variable name is not appropriate. It will not work in C#. It needs to start with a letter. Same thing with number 4. Again, this one starts with 1. They need to start with a letter, capital or lowercase, but it cannot start with a number. Number 5 is inappropriate because of this hashtag, number, pound, whatever symbol you want to call it there. You can only contain, or you can only have letters, numbers, and underscores in your variable name. That hashtag is not allowed. Same thing with number 6, the dash is not allowed. If you want to distinguish between two words, my advice is to write something like game and then capital T, time, to distinguish that the next word is starting. Then the rest in the middle are okay. Note that this underscore is okay. It's the one symbol that is allowed. And then in number 10, same as number 6 and number 5, that exclamation point is not allowed. You cannot have an exclamation point in your variable name. So now that we've got basic variable naming down, we're going to talk about variables being declared and initialized. So all variables to start must be declared and initialized before they are used in a program. So we're going to talk about what a declaration is, what an initialization is, and then from there we'll talk about how we can do these in separate statements or in one combined statement. So a variable declaration is essentially what gives the variable a type and a name. You're basically declaring, I am going to create an integer variable with the name score. That is what you are doing when you declare a variable. So notice that you're giving it a type and you're giving it a name. You don't have to give it a value, but all you need is a type. And a type is one of those 6 variable types we talked about on the previous slide. So those are one of those 6, the byte, the int, the double, the char, the string, or the boolean. And then from here, your identifier is another name or another word for name of your variable. So that's what your identifier is. So note down here that these are both declaration statements. We have the type followed by the identifier or the name. So I'm creating an integer variable named score, or I'm creating a byte variable named red. So notice that a declaration requires us to give a variable a type and then to also give it a name. That is it. Now, once a variable has been declared, we can initialize it. And so initialize, is giving that variable a starting value. So You're going to use your identifier, which is, remember, the name of your variable, and that is unique. So that's your name of your variable, the name of the variable that was holding a piece of information. And we're going to assign it an initial value by using this equal sign. So what you'll notice here is that I have score. Score is my identifier. Score is my name of my variable. And what I am doing is I am assigning score a value of 10. So in the location that is named score in computer memory, I now have stored the number 10. Now if we look down at the second one, red is a different variable name, a different location in memory, and in that location in memory, I have saved the value of 0. So declaring is giving a variable a type and a name for the first time, and it is only done once in every program. Initializing is when we are giving that variable an initial value so that it has a value to start with when it is ultimately used in our program. So it needs to have some sort of value so that if we ask, our counter to add 1, we know what counter is currently equal to so that we can actually add 1 to it. If counter is never given an original value, it doesn't know what number it should be adding 1 to. So I showed you how you can do your declaration in one statement and your initialization in another, but I do want to show you how you can do your declaration and your initialization in the same statement. So what you can do at the beginning of your program is you can declare it and give it an initial value right off the bat. So what you'll see here is I've kind of combined the two together. So you'll see, okay, I have int score. So that's the type of variable and the name. That is my declaration. So I have the type and I have the name. But what I've also done is I've extended this statement and I have score is equal to 10. That is my initialization. I'm taking my variable and I'm setting it equal to something for the first time. So what I've done is I've declared and initialized in the same statement. Same thing here. I have a byte type variable named red. That is my declaration. And then here in pink, I'm setting red equal to 0, and that is my initialization. So if you're more comfortable having your variable be declared and initialized in the same statement, you are more than welcome to do that. You can do it the other way where you have two separate statements, or you can do it just in one. It's up to you. So what I would like you to do is for each of the 4 variables below, I'd like you to take a notebook out, and I'd like you to write a declaration, an initialization, and then a declaration and initialization together in one statement. So it's going to take a little bit of space. You're essentially going to have 3 lines for each, and you're going to write them out. Now, if you're unsure of what to do, I will walk through the first one with you, and then from there, leave it up to you to do the remaining 3. So I want you to write a declaration, an initialization, and a declaration and initialization together, and then on the next slide, I will show you the answers. All right, so for example, in this first one, it says I have an integer variable, so I know that that is my type. And I have it called age, that is my identifier. And it's going to hold my age value in memory. So the first part, part A, my declaration, is just the type and the identifier. So I have my type, which is int, and my identifier, or the unique name for the variable, which is age. That entire piece there is my declaration. Now from here, my initialization is where I give my variable its first value. So it says to take my variable name, which is age, and set it equal to my current age, which is 27. So that's my initialization there in blue. Now this last piece, I'm asking you to write a declaration and an initialization together. So in part C, I'm going to have my declaration part, which is int age. I'm giving it a type and a name, and then I'm initializing this value to be equal to something to start. So there's my initialization. So I can see here that I have my declaration and my initialization all in the same statement. So what I'd like you to do is pause the video here if you haven't done so already, try the next 3, and then you can see the solutions on the next slide. All right, so here I would pause the video and check what you've written down. Do you have a declaration, an initialization, and a declaration and initialization in the same statement. So look at parts A, B, and C for each answer. A couple of things I want to point out to you. When you have a string, note that when you're initializing a string, you have these quotations here. So that is telling you that that string, whole thing will be saved inside of first name. So just kind of keep that in mind. But from here, you should be checking your answers. How did you do? Can you distinguish between a declaration, an initialization, and both being done in the same statement? If you can, you're good to go. You can move on. If you're not, this is a good place where you should be asking a question to get some clarification on declaration versus initialization. All right, so the last thing I want to talk about is something called variable assignment. And you've used equal signs to assign values already as you've practiced your initialization, but I just want to retouch on this before I move on to objects. So keep in mind right here that this first statement right here has a declaration right here, and it has an initialization right here in red, excuse me. So what you'll notice is that I have my declaration and my initialization. And what we can do is we can actually rewrite that value to save a different value in memory. So over the case of a program, it's not uncommon for a variable to change value. And every time it does, that is called reassignment. So you are essentially reassigning that value to hold, or reassigning that variable name, excuse me, to hold a different value. So here you'll see that score is equal to 50. So what happens is when it gets to this point in the program, the variable score is holding the value 50 and erases and forgets that original value of 10. So it forgets that it ever held the value for 10. And then from there, as it continues on in the program, again, it gets to a point where it changes its value to 20. And what happens is, at this point, score is now equal to 20, and it forgets that it was ever equal to 50. So throughout a program, you can reassign variables to have different values, but something to remember is that your variable name will not remember what it was originally set to. So it will not. It will only remember what it is currently equal to, and that is it. From there, it will then use that value that it is currently equal to perform different actions within your program.